Hi everyone. So in this video I'm going to go through how to use a popular NLP library called spaCy. And then in the following notebooks, which you'll be going through live, you'll see how to use tools built on top of spaCy for specific clinical NLP tasks. So before starting this notebook, make sure that you've watched this earlier presentation with an introduction of myself and of what NLP is in general. So spaCy is a popular tool which is built in Python and is used often for NLP projects. So it offers a lot of out-of-the-box tools for processing and analyzing text. And what's really great about spaCy and what has allowed me to be successful in a lot of projects is that it's very flexible and that you can add on to it and extend it and use tools built by other people in the open source community. So what we're going to do today is we're going to look at some of the basic uses of spaCy, give you a general sense of how this works, and then we're going to go on to see how we can use it to do clinical information extraction tasks. So I encourage you to go into these links here. So spaCy has really great documentation, so you can click through, let's see, I'll open this up for a minute. An overview of what spaCy, of how to use it, how to download it. You won't have to do too much installation here. We'll go through some of these features here, but this is a lot more detailed and they give really great examples and explanations. They also have a really good course, which they've published for free online, Advanced NLP with spaCy. And you can see that here they have 4 chapters where they give you really detailed examples of how to use spaCy and explanations. And a lot of what we're going to do today builds off of what these chapters talk about. And this is available in a few languages as well. Okay, so in this notebook, we're going to start just by looking at a few features of spaCy. We're going to start by seeing just how do you get started with using it. So the first thing that you do is we've already imported our spaCy library up here. And the first thing that we do is we load an NLP model. And we do this by spaCy.load and then the name of the model. So NLP equals, then we take some text that we want to process, and this is a quote from a business article, and we call NLP text, and that takes our text and it runs it through our NLP model. And it returns a doc object, and the doc is our processed NLP text. Once you do that, you can do various things with it, like look at entities are extracted or certain linguistic attributes, and we'll go through these in more detail. But first, now that we've seen this general high-level workflow of how spaCy works, let's look at the architecture and what kinds of classes we're working with in spaCy. So first, we're dealing with a model, which is typically called NLP. And there are a lot of different models. So this one is called Encore Web SM. That stands for English, the core kind of web data, and it's a small model. But if you open up their documentation here, you can see that they've got a lot of different languages that you can use. So depending on what kinds of tasks you're doing, what data set you have, all of these options are available for you to download. And you can use them all in a similar way. So as we saw before, when you take a text and you run it through the NLP, it returns a doc. And this is of the doc class, and it represents a single processed document of text. And you can see that it looks exactly the same as the text before, but once we look under the hood, we are going to see that there's a little more going on. So a doc is made up of individual tokens. So in linguistics or NLP, a token is an individual word, and it might not be a word in the way that we think of it. It could be a symbol or a white space or part of like a composite. And we can access each token in a doc similar to what you would do in a list, so by indexing. So if you do doc 0, that's going to give you the first token in the doc, which is taco here. This is of class token. And you can see that if we iterate through all of the tokens, it prints out what each token is. So you can see here that it's not always just like words the way that we think of. The way that I would typically define a word is it's maybe broken up by white spaces. You can see here that apostrophe S is broken apart from bell. Comma is treated as its own. The dash is breaking up a word. But this one, A.M. that's treated as one token, even though maybe you would split on punctuation there, like you do other places. So tokenization is a little more complex than just breaking up by white spaces, but it's basically just breaking up your text into individual words. So a single unit is a token, and a range of units is a span. So you can access a span similarly like a list. So if you look through 1 through 4, then that's going to give you tokens 1, 2, and 3 of the doc. So because spaCy comes with these pre-trained models, which have taken large corpuses of data and trained for linguistic tasks, these models come preloaded with linguistic attributes that we can use in our NLP processing. So a few examples of this. So one is part of speech tagging. So if you remember back to, like maybe elementary school, you learn what the parts of speech are. So like nouns, articles, punctuation, verbs, determiners. So each token is going to have a part of speech attached to it. Another is the lemma. So the lemma is the root form of the word. So if you look at these, let's see, you can see that latest gets mapped to late, opened gets mapped to open, and so on. One more thing that spaCy does is dependency parsing. And this is where it generates this structural representation of the sentence. So if you look at the sentence, the cat sat on the green mat, and then you go here, you can kind of navigate the structure of the sentence here. So if you start with this verb sat, you can see that the verb has a noun subject of cat, which has a determiner of the, so the cat sat, there's your subject and verb. And then there's a preposition of on, which has a prepositional object of mat, sat on the mat. And then there's a determiner and an adjective. So that's just a few of these attributes, and you can see the documentation for a lot more. So these are all kind of what we call low-level tasks in NLP. Like it's not necessarily useful by itself to know that bell is a proper noun, or that up is an or that hotel is a noun. But you can use these lower-level tasks for more useful direct tasks, like this one here, which is called named entity recognition, or NER. This is where we extract specific named entities from text. And what a named entity is changes depending on the domain you're working with. So right now we're looking at general domain. We're going to look at clinical stuff later, but for now we're looking at what is often referred to as general. And this usually uses news articles or Wikipedia articles as source text. So in this case, the named entities are typically proper nouns like people, geopolitical entities like countries, or organizations. So if we take this news article here, you can process it, NLP text, doc equals NLP text. And then you can use this function provided by spaCy. They have a module called spaCy, which is really useful to highlight the entities that are being extracted here. So you can see that Germany is a geopolitical entity. And if you have any questions about what these mean, you can use this explain function. EU is an organization, Peter Wittig is a person, etc. And then here's an article shown a little earlier, a business article. And if you extract it, you can see what it extracts here. And I like this because typically this model is doing quite well, like all of the labels that it's assigning are right. But one that I would say is maybe not so right is this here. So the Bell, a Taco Bell hotel resort, they call a work of art. So, this is the hotel that they're releasing, and it's kind of funny to call that a work of art, even if you really like Taco Bell. So one thing I would ask you to think about is, why do you think that it's calling it this? What about the patterns in the text here make it think that this is the name of a work of art, something like the Mona Lisa or the David? So once you've processed the text with NLP, we're highlighting all the entities here using spaCy, and you can also just iterate through them by looking at doc.ents. And for each entity, which is a span, you can look at the text of it and also the label here. So we can see for each of these entities what the label is that it's assigned. So how does spaCy do all of this? How is it generating this information? Well, let's take another look at some of spaCy's architecture. So underneath the hood, the NLP object contains various different components. In an NLP, this is called a pipeline. And in a pipeline, you take multiple processing steps and you pass the text through each one sequentially. And each component is going to do a different sort of analytical task on the text. So for example, when we take our standard model, we can use this attribute called pipe names to see what pipeline components are included. So this has a tagger, a parser, and an NER. And so here's a visual representation of what's going on here. So you take the text and you pass it into the model. The first thing that happens is it gets tokenized and split up into those individual tokens. Then the tokenized text goes into the tagger, which assigns the part of speech tags, the parser, which generates that dependency parse that I showed you above and figures out the structure of sentences, and then that goes into the NER model, which assigns the labels for the named entities. And you can see here, this is all that we have, these three components, but this ... in this diagram shows that you can add on to this. And again, what I really think is so great about spaCy is that it's really flexible. So we're going to see examples later where this is not what our pipeline looks like, and we're going to have pipeline components that are more specific to clinical tasks. So now let's try using spaCy with some clinical text and just see out of the box, what can this do for us? So we're going to take this text here taken from Mimic, 76-year-old man with hypotension, CKD stage 3, status post-RAJ line placement, and SWAN. What happens when we process this? So look at these extracted entities. How did spaCy do with it? I would say not so great, right? So I would say that really none of these are relevant or correct classifications. This one almost, 76-year-old, it's calling it a date. But, really that's more of like an attribute about a patient. It calls CKD stage 3 a product. That doesn't make any sense. RIJ, an organization, which I can see why it thinks that because organizations will often have these kind of like 3-letter abbreviations. And SWAN maybe is, the name of the person who invented this procedure, but it's here talking about the procedure, not the person. So think about why did it make these mistakes and what would we want spaCy to extract? Looking at these sentences, what labels or classes would we be interested in extracting? And what kinds of steps would we have to take to find them? So that's what we're going to focus on for the next few notebooks. So I'm going to go over to the directory here. So you'll be completing today any of these notebooks which start with NLP. So you're going to start by looking at how to use NLP for concept extraction, writing rules to be able to extract some of the entities that we're actually interested in. Then you're going to go on to use machine learning model, to use some other pipeline components to extract additional things like negation or temporality. And then as a workshop, you're going to apply the tools that you've built to a few different clinical tasks and data sets. So I will be available on Slack. My name's Alec Chapman, and the other instructors will be available to help as well. So let me know if you have any questions, and I hope you enjoy working on these and learn something from them.